Hi friends, how are you? I am your friend Chiwe from Nostec Academy. We have this examination question here. This is under Earth geometry. So this question is saying A, B, C, and D are points on the surface of the Earth as shown in the diagram below. So this is the diagram. You have A, B, C, and D here. Then you are asked, the first question is, using latitudes and longitudes, write the positions of the points A and D, A and B. Okay? A and B. And this is 2 marks. All right? This is 2 marks. Then this is 1 mark. This is 2 marks. Then the last one is also a mark. So 6 marks in total. Okay? So, how do you write positions? Remember, my good friends, positions are written in the form of coordinates using latitude and longitude. Okay? Using latitude, comma, longitude. So position A, let me write answers here. Position A, look at A here. You ask yourself, where is A? A is here. You ask yourself, question 1, in which latitude is point A? So the latitude, these are lines that run from west to east like this, okay, like this. So it is A is on latitude 60 degrees north, comma, on which longitude? It's on longitude 51 degrees west. So we're going to write 51 degrees west. Okay, close bracket. So we are done with A. Then we go to B. B, look at B. B is here. You ask yourself, on which latitude is B? B is on latitude 80 degrees south. So I'm going to write 80 degrees south, comma, the longitude is 51 degrees west. 51 degrees west, like this. Okay, so that is the first, that's the first solution to the first question. Second question, find the difference in longitude between points C and D. Look at C and D. C and D are on the same latitude, meaning we have to find the difference in longitude. C is on longitude 31 degrees east, D is on longitude 81 degrees east. So they are on the same side. Okay, so what do you do? So question 2, on the same side we subtract. Okay, on the same side we subtract. Since C is on the position of C is 80 degrees south, comma, 30 degrees east. Okay, then D is on 80 degrees south, comma, 81 degrees east. Okay, so since they're on the same latitude, then we're going to find the difference in longitude. Now, difference in longitude, check if they're on the same hemisphere, we subtract, different hemispheres we add. So here is east-east. So we're going to subtract, we're going to say 81 degrees east minus 31 degrees east. Okay? So 81 minus 31, it is what? It is 50. 50 degrees. Is it 50 degrees east or what? Just 50 degrees. You just leave it the way it is as 50 degrees. Are we together, friends? Okay, so that is the difference in longitude between point C and D. Question 3. Point 3. Question 3. Calculate the distance CD in nautical miles. CD, here, CD. Calculate the distance CD. Wow, this is nice. In nautical miles. So since this is the distance in latitude, okay, along the line of latitude, the formula is like this. So it will be CD is equals to theta over 360 degrees times 2 pi r cos x. Okay, like this. So then you need to understand a few things. If this formula can further be reduced to 2 here, 1, 2 here, 180. So this formula can also be written as theta over 3 over 180 degrees times pi r cos x. Okay? Then, what is r? R is the radius of the earth. Since here we are told that it is 34, 37 in nautical miles, so we're going to write 34, 37 is in nautical miles. Okay? Then x is the latitude in which the 2 points are. So when you look at CD are on latitude what? Latitude 80 degrees south. So x is 80 degrees. All right. Then theta, here this is a difference in, since the distance is in latitude, then this is the difference in longitude. Difference in longitude between C and D, of which we've already calculated is already 50 here. So it's just a matter of substituting. When we substitute here, we are going to say CD is equals to, where there is theta here, so if it is already 50. So where there is theta, we're going to substitute with 50, and we're going to write 50 here, degrees over 180 degrees times pi is 3.142. By the way, this is the last thing, is 3.14. It's a thing that I forgot. It's already given in the question there, 3.142. So we're going to write 3.142. Okay, times radius, yes, it is 34, 37. Then cos x is the latitude in which CD are, which is 80 degrees. Okay, so we're going to write 80. Now we can calculate now 50 over 180 times 3.142 times 34, 37 cos 180. Okay, so let's do that. So CD, after calculating, we find this is giving me 512.89889902118966. This is what is giving me. Okay, now the degree of accuracy is not specified here. So the ECZ exam states that if the answer is not exact and it's not in degrees, we should leave our answer correct to 3 significant figures. So we have 1, 2, 3. Then after this 0 here, this is the third significant figure. This is the third significant figure, and then after this one, there is 8. So 8 is greater than 5, meaning we're going to add 1 to this 0 and it becomes 1. So it will be 521. What are the units? In nautical miles. Okay? In nautical miles. So this is the answer. Now, you should be careful. We're remaining with the other question, by the way. So you should be careful here as you're calculating. Make sure your calculator is in the right mode. Be careful again on the formula. The formula for calculating the distance along the line of latitude is we add cos x, r cos x. Then along the line of longitude, we add nothing. Okay? Now, look at this. The last question is saying, given that the local time at D, the local time here is 1305 hours. Find the time at C behind. So since the C, they are all in the same hemisphere, east, but this one is behind this one. So we're going to subtract the time difference. Okay? So this is how time is calculated. First, we find the difference in longitude between C and D, of which we already know the difference in longitude is what? 50 degrees. Okay? Difference in longitude is 50 degrees here. Let me just write nicely. Difference in longitude. Okay, difference in longitude is 50 degrees. Then we should now find time difference. Okay? Time difference between two points. Time difference. Now, time difference is this one. 1 hour is equivalent to 15 degrees. Then dash hours, we want to find the difference in time, is equals, so dash hours is equals to 50 degrees. Okay, then we cross multiply. When you cross multiply this times this, it will be 15x is equals to, this will be 50. Okay, so like this, 15 over 15 here. Then 15 into 30 there, into 50, it goes there 3 times. 3 times remainder 5. Okay? 3 times remainder 5. So it goes there in 45. In 45, it goes there 3 times. So remainder 5. So that remainder 5 is 5 degrees. Okay? So let's use the other conversion again. So I'm going to say 4 minutes is equivalent to 4 minutes is equivalent to 1 degree. Then dash minutes is equivalent to 5 degrees. The remainder there, you should remember, okay? So after cross multiplying, we're going to have x is equals to 5 times 4, 20 minutes. So time difference therefore is 3 hours, 20 minutes. Okay, 0320 minutes. So this is the time difference. 3 hours 20 minutes. This is the time difference. Now let's find the actual time between. So finding actual time, we do like this. At D, look at D here is 11. What's the time? 13:05. Okay, then at C, we want to find, they're asking us to find at C. So since the C is behind D, okay, it's not in front, D is in front, and D, we are asked to find the time behind here. So what we're going to do, we're going to subtract the actual time. So we're going to say 13:05 there minus 3 hours 20 minutes. Okay, 3 hours 20 minutes. So when you subtract 5 minus 0 is what? Is 5. Then is 0 minus 2. So when you borrow 1 from this 3, it becomes 2. So in other words, you're borrowing 60. Since these are hours and these are minutes, so 60 minutes. So this one becomes 60. 6. Okay, and 6 minus 2 is 4. 6 minus 2 is 4. Then here 12 minus 3. 12 minus 3 is what? 9. 9. Okay, so this is the answer. So the actual time at C is 9:45. Meanwhile, at D here, it is what? It is 13:05. So that's how you calculate time. Thank you so much for watching. Remember to subscribe.